All right, what you're going to see here are some more coordinate proofs where we look at specific formulas to tell us things that are true about the shape that we're looking at. And so the two key things that you're going to see throughout these problems, the two key things is that if we are interested in parallel or perpendicular, the information that's going to tell us about parallel or perpendicular is the slope formula. So if I have a definition that involves needing parallel or perpendicular lines, I want to look at my slopes. Parallel, the slopes should be the same. Perpendicular, opposite reciprocals. Change your sign, flip your fraction. Then, if I want to know about congruent, if I want to know about sides being congruent, sides being the same, then I want to use our distance formula. And if things have the same distance, then they're going to be congruent. So that's what we'll see. In the shapes, we're going to look at what do we want to be true about the shape and what formula does that mean that we're going to use. So that's what you're going to see on each of these examples. And on each of these, I'll try some formulas, and then I'll have you try some formulas. So first off, we want to prove that ABCD is a kite. So you want to look back in your chart and in your notes and find your definition of a kite so that we know what we're looking for and know what formula that we're going to use. Here are our 4 coordinates. And remember that in a kite, I want the consecutive sides to be congruent. And if I want to know about consecutive sides being congruent, then the formula that I want to use in that case, the formula that I want to look at is my distance formula. Distance formula because I want to know about sides being congruent. And the distance formula is what helps me figure that out. So looking at our distances, we're going to start with my distance from A to B, and we're going to compare it with the distance from B to C. So to start with, our distance from A to B. Our distance from A to B is going to be, subtract your x coordinates squared, so that's going to be -1 minus a -1 squared plus subtract your y coordinates squared. The y coordinates here are 5 and 2, so we're going to subtract those and square it. And that will equal -1 minus a -1 is -1 plus 1, which is 0. 5 minus 2 is 3 squared. So we'll look here, 0 squared is 0, 3 squared is 9, so we get the square root of 9, which is 3. So then we want to compare the distance from B to C. And I'll pause here for a moment and see if you can come up with the distance from B to C. Remember, we want it to be congruent, so we should also get square root of 9 or 3 for this other distance. And there's your formula for you to check. And lo and behold, we wind up with 3. So therefore, A to B and B to C are congruent. So we have our first pair of consecutive sides congruent. Now let's look at pair of sides number 2. which is that we're going to look at C to D, and we're going to compare it with D to A. And again, we're looking for both of these to match. So starting with my distance from C to D, square root. Subtract the x-coordinates. The x-coordinates here are 4 and 2. We're going to subtract them squared. And then my y-coordinates here are 0 and 5. We're going to subtract them squared. So important thing here to point out about the distance formula. Remember that when you take your distances and get to this part where you're squaring it, if you are squaring a number, you should always get a positive number. Even if I take a negative number and square it, I'm still going to get a positive. Because here I get 4, and then negative 5 squared is a negative 5 times a negative 5 is a positive 25. So I wind up with square root of 29. Make sure if you're taking a negative number and squaring it, you should get a positive number. So with that in mind, we have our distance from C to D. Pause here and see if you can get your distance from D to A. I'll give you a hint. It should be the same thing. And here comes your answer. Hey, look, it's square root of 29. Therefore, C to D and D to A were the same, which means that because the consecutive sides were congruent, that means that we have our kite that we were looking for. And remember, we used distance formula because we wanted to know about sides being congruent. So that meant we used distance formula. Next problem. This time we want to prove it being a rectangle. So if we want to prove it being a rectangle, that means that all the angles are congruent. That's not distance formula, because distance formula tells me about sides being congruent. If all the angles are congruent, that means that all the angles are right angles. All the angles are right angles. So that means if all the angles are right angles, then that means that the lines are perpendicular. So really what I want to check for is those lines being perpendicular. And if I want to check for perpendicular, we're going to use slopes. And so I'm going to check all my different slope formulas for all my different sides. And I want to make sure that those slopes are opposite reciprocals. Change your sign, flip your fraction. So we're going to find all these different slopes and we're going to compare them to each other. So I'm going to start here with P to Q. Change in y over change in x. We have y coordinates are 4 and 2. We're going to subtract them. And x coordinates are 4 and negative 4. And we're going to subtract them. So 4 minus 2 is 2. 4 minus a negative 4 is 8. And so we get 2 over 8, which reduces to 1/4. For Q to R, the slope will be change in y over change in x. Y coordinates this time are 0 and 4. We're going to subtract them. X coordinates are 5 and 4. We're going to subtract them. So then we have 0 minus 4 is negative 4 over 5 minus 4 is 1. And there's our opposite reciprocals. Change your sign, flip your fraction. So we have our slope of positive 1 over 4 and our slope of negative 4 over 1, which means that we have our right angle that we were looking for, our perpendicular lines that we were looking for. So now, try the rest of your slopes, which are my slope from R to S and my slope from S to P, and see if we get those opposite reciprocals that we're looking for. And hopefully these are the slopes you got. All of these, you notice, have opposite reciprocals. So we have P to Q and Q to R and R to S and S to P and P to Q. All four of them have our slopes being opposite reciprocals, which means that all four of them are right angles, which means that we have the rectangle that we're looking for. So just to remind you, we were looking at slope because we wanted to know about those lines being perpendicular. And the thing that tells us that is our slope. One more problem. And we're going to be looking at our trapezoid. So make sure that you look through and find what your definition of a trapezoid is, and see if you can use that definition to figure out what we're going to be looking for in our trapezoid. So here are our coordinates. And remember that a trapezoid has one pair of sides parallel. So if we're looking for the sides to be parallel, the formula that we're going to look at is our slope formula. Because remember, the parallel lines should have the same slope. And by the way, one pair being parallel means that the other pair is not. So let's make sure we keep a close eye on what formulas we should be paying attention to here. So we have Q to R. We're going to start with our slope of Q to R. This is the only one I'm going to do, and then I'm going to let you pause and try the other ones so that you can check your work. Q to R, our slope is change in y over change in x. So we have change in y is 4 minus 3. Change in x is going to be 4 minus a negative 2. So 4 minus 3 is 1. 4 minus a negative 2 is 6. So we have our slope of 1/6. So pick out what slope you want to compare that to. Well, the slope we want to compare that to is the side that's across from it. So the side that's across from Q to R is going to be P to S. And remember, we want one pair of sides parallel and the other to not be parallel. So one of these pairs of opposite sides, we want them to be matching. The other pair, we want to not be matching. So I'll pause for a moment and let you try those and see what slopes you get. First of all, for P to S, here's our matching slopes. 2 over 12 reduces to 1 over 6. So that means our lines are parallel. But that's not all we want. We want the other pair to not be matching. So my other pair should not have matching slopes. And we see that P to Q is 3 over 2. R to S is negative 5 over 2. So there's our other pair of slopes not matching, which is what we wanted. Therefore, only one pair of sides is parallel, and we have the trapezoid that we're looking for. So on each of these problems that you're looking at, you want to look at the definition and use that to figure out which formula do we want to use. I'll just make one more note that on the last problem, it doesn't say which formula you're looking at, which kind of shape you're looking at. So you're going to use 4 slopes and 4 distances to figure out which shape we're looking at.